Kimi K3 keeps 896 experts in every layer. To write one word, it wakes 16. The whole model is 1.5 terabytes of weights. It does not fit in your memory or in almost anybody's. Somebody is running it anyway on a 5-year-old MacBook, 3.76 seconds a word. That is 16 words a minute. You could type faster. So this is what it costs to run the largest open model on Earth, on hardware a person can own. 4 tricks, most of the model never runs. It was already 4 bits when you downloaded it. Half of what does run gets shrunk again. And a smaller model guesses ahead, so 1 trip delivers several words. Then the 3 places this stops working. Start with the file, because the file is the whole problem. 2.8 trillion parameters, 93 layers, a million tokens of context. And weights you can download right now, for free. 96 files. 1.5 terabytes. For most people, that is not a download. It is a shopping trip for a bigger drive. The normal way to run something too big is to shrink it. Unsloth published a ladder of squeezed builds. The smallest is 594 gigabytes. The rest climb back toward the original. Shrinking it that hard still does not get you to a machine you own. That is the road most people go down, and it runs out. Deltafin takes the other road. It does not shrink the model at all. The README puts one rule above everything else. Speed must never come from reducing model quality. All 16 experts, every time. That is enforced in the code, not just promised. Set it lower to buy speed, and the program refuses to start. Trick 1, and it is the one that makes the other 3 legal. 92 of the 93 layers are expert layers. Each holds 896 experts, and the router picks 16. So 16 times 92 is 1,472 experts. At roughly 17.5 megabytes each, that is 25.8 gigabytes for one word. That is the trip. 25.8 gigabytes instead of 1,500. That is trick 1, and it is most of the win. Trick 2. Why is a 2.8 trillion parameter model only 1.5 terabytes? At the precision most models ship in, it would be about 5.6 terabytes. K3 ships in a 4-bit format instead. And here's the part I think matters most. Moonshot did not squeeze it down afterwards. They trained it that way. Quantization-aware training all the way through. Which is why the trip is 25 gigabytes and not 100. Trick 3. Split the model in 2 and shrink the half that never leaves. There is a spine. The attention layers, the shared experts, the embeddings, about 114 gigabytes, and every trip reads all of it. Then there are the 82,000 routed experts, 1.5 terabytes of them, and a single trip touches almost none. So the spine gets converted to 8-bit integers. 107 gigabytes becomes about 53. Half the bytes, no meaningful quality change. And here's why these tricks are not a list. On a contributor's Linux box, the same completion went from 865 seconds to 221. 4 times, not 2. Having the spine did not just move fewer bytes. It freed enough memory for the expert cache to actually work. Quantization changed the read pattern, not just the arithmetic. 3 tricks in, and the trip is about as cheap as it is going to get. Which leaves a wall. The trip costs what it costs. 26 gigabytes every word, forever. You cannot optimize your way under that. So the 4th trick stops trying to make the trip cheaper and starts making it count for more. A tiny assistant model, small enough to sit in memory, guesses the next several words. Then K3 makes 1 trip and checks all of them at once. Every guess it agrees with is kept. From the first one it disagrees with, the rest are thrown away. The small model never gets to write anything, it only proposes. K3 remains the only thing that decides what reaches the page, which is why the output is identical either way. And the numbers are clean because they ran the control. Speculation off, 12.5 seconds a word. On, 4.7, 2.68 times faster, and the exact same words came out. In the reference run, 16 words were delivered, by 3 trips instead of 16. The trip never got cheaper. It stopped being charged once per word, which is how you get to 3.76 seconds a word. 4 tricks, and the last one made nothing cheaper. Now the bill, because I promised you the places this stops working. There are 3, and the project is louder about them than I am. Everything so far was about writing. Reading is a different bill. The first token on a 5-word prompt takes 23 seconds. A chat prompt is 60 tokens or more. And a normal client sends the whole conversation again every turn, which Deltafin currently rereads from scratch. Their own line about coding assistants is that they are a curiosity, not a workflow. Second, it only does greedy decoding. Temperature and top P are accepted and then ignored, so there is no dial for creativity. And it handles 1 request at a time. A second gets a 429. Third, and nobody optimizes this away, stream it on 215 gigabytes. And it is 3 minutes a word. Install all 1.7 terabytes, and you get the number I quoted. And even with everything local, the 53 gigabyte spine, plus the draft assistance, does not leave room for the expert cache. So much of it is reread every trip. The maintainer says it plainly, and I want to read it exactly. This is a research artifact, not a practical chat setup. Interesting mainly as an existence proof. So, good enough to prove a 2.8 trillion parameter model will answer on a machine you own, and to study how. Not good enough to write code with. For years, running a model locally meant one question. Does it fit? That was a fair question, and for dense models, it still is. This one will never fit. What it costs now is not capacity. It is how few bytes you move per word, and how many words you get for each move. The repo is linked below, and it is MIT licensed. The README is a good hour if you have got the disk. If you try it, put 2 numbers in the comments, your seconds per word, and how much RAM you have. Those 2 together are the whole story.